Good evening, everyone. I know it's very late during the day. I'm sure the caffeine is wearing out for you guys, but bear with me. It's going to be a very straightforward session. We are going to keep it very simple. And we are going to talk about CopperPoint's cloud native blueprint, specifically from an insurance angle. My name is Sid Dixit. I'm a principal architect at CopperPoint, along with Sham Rao, and we are going to talk about the cloud native journey that we have been through as a part of CopperPoint Insurance. So the insurance industry isn't like a move fast, break things kind of a industry. It's a regulated industry. We deal with a lot of sensitive data. We deal with a lot of, auditors. We are accountable to auditors. We are accountable to regulators. We are accountable to policyholders and agents, right? But that doesn't mean that we as an organization ignore modern architecture. What it means as a part of our cloud native strategy, or as a part of our cloud native story, our systems have to be designed to handle compliance, has to be designed to handle resilience, and has to be built upon trust. Before we move further, I think it'll be helpful to talk about who we are. This is our first, presentation at KubeCon, so it will be helpful for us to know what CopperPoint is and who we are, right? We are an insurance company. We started as a single line of business state fund out of Phoenix, Arizona, workers' compensation line of business back in 1925, way before I was born, right? In 2017, we acquired Pacific Compensation. Before that, we also became privatized, and then we became a mutual company called CopperPoint Insurance Company. And in 2017, we started our journey of expansion. We acquired Pacific Compensation, which allowed us to expand our business to multiple states, including California. In 2019, we acquired Alaska National Corporation, and that allowed us to grow organically across different business lines other than workers' compensation, right? Be it property, be it commercial auto. So in 2019, after acquiring Alaska National, we started expanding further. It was not until 2023 we decided to move all our infrastructure, our workloads from on-prem to cloud, and we completed our integration of all of these systems and all of these acquisitions that we did in the last few years, right? And 2025 is the year when we are celebrating our 100th anniversary as an organization. So our journey has been not very easy. We have been growing aggressively. We have had multi-state, multi-product expansion. We have, acquired companies. We have grown organically as well, but and at the same time, we have been very aggressive while doing that, right? We want to make sure that while we are doing all of that, we want to not only focus on revenue but also remain cost effective. We want to unlock latest and greatest cloud innovation, including AI and Gen AI within our platform. And we want to ultimately provide superlative experience to agents, brokers, and policyholders. But during this journey, we realized that being on cloud was not enough. What we really needed was to build a way the cloud was meant to be run. And that's where the cloud native principles provided by CNCF Foundation comes into picture. We wanted to adhere to all the principles, including containerization, microservices, composable and event-driven design as a part of our architecture to support good customer experience, right? So just to give you some numbers over here in production, we have 100+ integrations running in our production environment, servicing our policy, billing, and claim system, which is a SaaS product called Guidewire. We have 100+ reusable APIs. So what we built as a part of those integrations are reusable APIs. So if a new vendor or a new integration wants to talk to us, let's say wants to send documents to our document system, we could leverage some of those reusable endpoints. We have built reusable job templates that powers 600+ job pipelines. but we also run a lot of our jobs as a part of plain vanilla Kubernetes cron expressions. We have also built 500 plus data pipelines. Our enterprise data warehouse is still on-prem, and we are pushing all of the data that we are generating from our core systems in cloud all the way to our on-premise data warehouse through the data engineering pipelines that we have built using Databricks. And we're going to touch upon that later. So what are the benefits as a result of that? We not only reduce our incremental cost as we go cloud native. We accelerate our time to time to market. We are able to provide real-time streaming data, and this is particularly important. Now, our business stakeholders, they don't have to wait a day, end of the day, or maybe a month to generate a report or something. They will be able to use our pipeline to get real-time data, right? So we have, with the help of cloud native architecture, we have actually been able to not only accelerate our time to market, but also we have been able to achieve a true platform mindset through cloud native architecture. Before building our cloud native journey, before going into our cloud native journey, I think what we had done was we had two principles that we had to follow, right? It's pretty straightforward. We had to start with low cost. We wanted to make sure that our systems cost less, and every cost it should cost less, and it should have a measurable value associated with the cost. The other requirement was pretty straightforward and simple. We need to scale and support scalability as we grow and as we expand. But at the same time, we also wanted to make sure that we keep things simple. So before we started our cloud native journey, we wanted to do some sort of capacity planning. And the way we did capacity planning was we examined our current workload. And what we did was we multiplied 10 times the load when we did the capacity planning. And we also kept into consideration a 10-year plan, because this infrastructure is going to be there for a while, and we need to support a 10-year strategy based on whatever infrastructure we build, right? We also accept the fact that technology is continuously evolving. We want to make sure that our architecture is nimble enough so that we can accommodate changes often as and when the technology changes. And our goal is to lean on open source, CNCF projects wherever possible, and only use third-party SaaS solutions when it makes sense, when it delivers value, right? So based on these principles, I'm going to share our cloud native context. I know it's a big diagram, a lot of moving pieces, a lot of parts, but let me break it down for you a little further. On the top, we have our core systems, which is our Guidewire platform, where we administer our policy billing claims, our contact center. At the heart of it, which is on red, is something known as Wild Donkey. I know it's an interesting name, but this is our integration layer that powers our integration right now. So with Wild Donkey, we are able to connect the APIs from our Guidewire system and also connect to our external vendors. With Wild Donkey, we are also able to transfer files from our vendor SFTP systems, such as bank SFTP servers, to our cloud system. And with Wild Donkey, we are able to push critical data to our on-prem warehouse, where we run our EDW, Enterprise Data Warehouse reporting. We also push several critical documents to our document management system as a part of our integration architecture. On the left-hand side, you see a real-time stream. What this is a Kafka stream that streams data from our core system in real time to our Databricks platform. And that's where we do a true magic of building something known as Delta tables, where we have built bronze, silver, and gold zone, where we clean, transform our integration and our core data and push it all the way to our warehouse. And the way we are replicating the data to our on-prem systems is using a product called Fivetran, which seamlessly replicates the data to and from cloud systems to our enterprise warehouse for reporting. So all in all, we have tried to make our system with Wild Donkey pretty lightweight, pretty performant, and pretty modular. And our goal is to make sure that whatever we build here, we start very small. We have some serverless solutions running in cloud right now. We have an intention to also migrate them to cloud-native solution within Wild Donkey. So just to zoom out Wild Donkey a little bit more, it's pretty straightforward. It is, it runs on EKS. These are Quarkus microservice applications running on EKS, running on vanilla EC2 instances in multiple availability zones, and if needed, for DR, regional DR as well, right? So simple EC2 instances running microservices in Quarkus managed by AWS EKS, right? From the CI/CD perspective, we are using Jenkins, kept it very simple and straightforward. For logging, we are using Grafana. For cluster auto-scaling, horizontal pod auto-scaling, we are using Cast AI right now. And our intention is to use all our CD workloads to Flux CD eventually. We are exploring that in our non-production environment. We are also using Okta for authentication and authorization, and Keeper is our secrets management, preferred secrets management platform. And the way we are syncing secrets from Keeper to our Kubernetes environment is through secrets operator, external secrets operator, right? We're still leveraging a bit of cloud services provided by AWS. We're using Amazon Aurora as our database for these integration microservices. And we are using S3 for object storage and SNS for notification, and a little bit of Lambda, but we are going to migrate all of that into our Wild Donkey Kubernetes stack eventually, right? And this layer actually interacts with all of our enterprise systems, including some integrations that are hosted in MuleSoft, some of them through external vendors, and some of them residing on-prem, right? The result is pretty simple yet powerful hybrid architecture that we have combined with the flexibility of cloud as well as reliability of our core systems using best CNCF principles. We have not made the architecture complicated. We have started simple and small and made sure that it's nimble enough so as we scale, as we add new SaaS solutions, maybe a service mesh in future, we could easily integrate it to our existing architecture seamlessly. So with that said, I'm going to pass it on to another architect from CopperPoint, Sham, who's going to talk about more about what challenges and experience we had while migrating to the cloud-native architecture.
Thank you, everyone, for coming today. We're really excited to be here. This is our third year into creating this new architecture for CopperPoint. And it's very exciting for us because this brings us into probably, the most modern, great technology where we can actually scale with CopperPoint's aggressive growth plan. So, So our past challenges is really probably we've had some stumbling blocks. All of our integrations started out in a single Java application, and it was resource constrained. So we had probably 10 plus years of legacy deadweight complexity and maintenance problem. So in order to overcome those challenges, we are looking for a better solution. And we took a kind of a stumbling block, in my opinion. We went with the vendor pass solution. And with that pass solution, we kind of restricted ourselves and limited our growth, partly because of licensing costs and partly because of the restriction in the technology itself. So part of our management plan is that we really needed to figure out a way to move forward, and that involves the reason why we're here. Kubernetes kind of gives us that ability, and in order to migrate our system to Kubernetes, we really needed to reorganize how we think and work differently than we had been operating for kind of our legacy organizational structure. The goal here is that we could really reduce our expense by a lot, and that's how we are able to make this transition easily with management support. One of the things that we really had to do is figure out how to get from our past into the future, and that involves upskilling and creating a team that has, the ability to, learn new things and take us forward. And that's really the excitement behind all of this. For our vertical industry to move into a technology like Kubernetes with the latest and greatest stuff is super exciting. So we're absolutely thrilled to be here. Another challenge that we've had is that we at CopperPoint have heavily relied on outsourced knowledge and expertise, including consultants. And we're trying to make an effort to bring all of that knowledge and expertise in-house. And to do that, it involves we are still outsourcing labor and contracting out, but we are doing that in such a way that we're investing in those people and they will be with us for the long term. So this is the path to what I call freedom and flexibility. And really what we're trying to do is kind of learn from the past where we followed what we thought was best practice, but it really didn't work out for us. And there's a lot of talk about microservices, and we went gung-ho with vendor support and big name consultants. We took our tightly coupled application and we went full microservices, and that has become kind of a headache for us because we probably didn't need to go that far. So we're trying to look for middle ground now, and I call that molecular architecture, as opposed to atomic architecture like microservice would be. For CopperPoint in particular, we're a mid-sized company, and we have an aggressive growth strategy, but we have many applications that probably don't need this flexibility and granular nature of full microservices. So we are trying to bring that back a little bit to be more reasonable, save some cost, some maintainability, and also efficiency. We are taking the best practices from our recent vendor pass experience, and we're borrowing the architecture from that experience where it makes sense, but we are looking for middle ground. And part of that is really the strongest thing that we've learned from that experience is about reusable components. So I've listed a few reusable components that we are building in-house as part of our new application framework, and I'll just quickly mention those. We are abstracting database, message queues, Kafka, key value store registry, secrets and properties, and also storage, file storage, cloud storage, and integration patterns like file transfer for SFTP, et cetera. So we have faced a lot of challenges because we did not hire consultants to take us on this journey. So I would like to just recognize in the back of the room is Evan Erickson, who is the third member of our architecture team. And the three of us have kind of struggled to build this from scratch over the last 2 years. And we did this really from YouTube expertise, from people like presenting at this conference, and just knowledge from the internet, best practices. And it's taken us pretty far. And we did fairly well. And based on Evan's comments from this morning, we're doing really well. We chose all the right things. I think we joined the Kubernetes movement at exactly the right time. Some of the challenges we faced was secrets management. Our particular vendor was Keeper, and we did not understand the structure of Keeper. So we stumbled a few times to figure out how we could utilize the Keeper secrets mechanism to integrate with our Kubernetes. So we've kind of become experts in ESO, even figuring out where it didn't work for us and where it did work for us. Another difficult thing we struggled with was how to accomplish CI/CD. At CopperPoint, we're a mid-sized company, and our IT is probably not as sophisticated as more established or larger companies. So we are trying to catch up, and we have a plan to use all the modern latest technologies. We have debated Jenkins, Flex CD, Argo CD, all of those things, and we are still in progress. But figuring that out has been a challenge, and currently we are doing everything in Bash, and we're proud of it for the moment. But we are slowly going to migrate. Another difficulty we've had is figuring out where to draw the line between infrastructure and development. And it's been a learning curve, figuring out that Terraform cannot do everything that we want in the best way. So we have created kind of a line in the sand between infrastructure and what we believe is application configuration. So we basically do as much as we can in Terraform and keep it to static infrastructure. And everything else, we are currently using Bash. But that's going to change as soon as we get back to the office. So we made a few stumbling blocks in our production environment, and I'd just like to mention a few of them. And it's really about, this is probably our naivete for being beginners, but we have to know our limits. And because of the nature of our industry, we tend to overlog, and we will probably have to figure out how to not log as much. But for the time being, we are pretty much logging everything because we're still operating out of fear, and we don't know exactly what's going to come. So we have to figure out how to log more than our vendor SaaS products allow. So that involves logging really large requests to something outside of our Grafana. Another thing where we stumbled was with configuring resource constraints for our pod configurations. It's really important for our company in particular. We are slowly shifting to event-driven architectures, but currently almost everything we do runs in a batch. And these are long-running batches, and that causes a problem for Kubernetes scaling. As you know, Kubernetes tries to kill our pods and then restart them. So we learned the hard way, configure graceful shutdown timeouts for the purpose of our batch jobs. It's also important that with Kubernetes, we are trying to architect for concurrency and scale. And to do that, we also have to, figure out how to maintain that concurrency without having our jobs override each other. So we struggled in that way, and now we have locking mechanisms in place as part of our patterns. Okay, so these are our recommendations for anyone who's starting out. And the basic thing is Kubernetes is super complex. So take shortcuts, learn from others, just follow the formulas that other people have presented. And that's worked out pretty well for us. I recommend that we keep it simple. Start with basic kubectl and bash and grow as necessary into more complex Kubernetes technologies. The CI/CD, telemetry, and AI scaling, we've added all of these pieces, but it took a while for us to figure it out. And we did not expect that we would have it in place before our go live, but we did. Another thing I would like to stress is really this is about in-housing. Build and empower your teams and give them the power to do everything, at least initially. I think it's really important that, in order to pick up speed and momentum as part of the development, it's important to give all of your team members like the full insight and access to be able to deploy, develop, test, create resources as necessary. And that has worked out really well for us. In our legacy culture, that is not how we operated, and things move really slow. As part of this effort, we really have accelerated the pace by attempting to change that culture. Another one of our recommendations is really avoid that vendor lock-in. It's been really difficult for us when we don't have the freedom and flexibility to solve problems that we need to solve. Part of the problem is licensing and money. But if we do it ourselves, like we can with Kubernetes in the open clouds, we are able to save money, and we are able to scale and expand as necessary without the tight budget constraints that we were facing previously. So that's a huge win. Another thing is we have really benefited from AI. So a lot of the public knowledge that's out there, including the YouTube and all the guides that are out there, get distilled into AI, and it makes it super fast, super fast. Without AI, I'm pretty sure that we would not be speaking at this conference today. Because of AI, we were able to get here within a year and a half, and that's pretty amazing. I highly recommend that you empower your teams to use AI wherever possible. Another thing I highly recommend for teams starting out is to just automate the developer environments and the rollout environments. It makes a huge difference if you take away all of the most difficult and tedious tasks. So just automate that stuff. At CopperPoint, we have struggled with that for almost as long as I've worked at CopperPoint, but now, at least within our new teams, we have scripts to automate all of that stuff, and we can get a new developer up and running within a day. And I think that's pretty awesome. I highly recommend also use Linux, use WSL. Keep people away from anything other than Linux. It makes it so much easier to automate developer environments in Linux compared to Windows or Mac or anything that uses anything other than apt install. It's beyond me. And VS Code is pretty awesome too. I'm new to VS Code. I've learned it all just within a year, and I am not looking for any alternatives. I've been super happy. And by the way, our team, basically, I'm probably the primary developer. And in addition to the three of us who are here in this room today, we have offshore team. And our offshore team developers, the intention is really that I would clone myself as each one of them. So all the expertise that I have gained has been scripted and put into bash scripts or other scripts or code, and that knowledge would disseminate amongst all of them. And really, the goal here is that we operate as one mind and just keep moving forward, forward, forward. Everything is code, everything is documented, and knowledge is shared. So this is CopperPoint's prescribed architecture. We have Terraform, Jenkins, Fluxcd, and we will probably be investigating more things also. We're currently using Cast AI. That's our before going to prod. I think that was our last major addition, and let me just forward through all these. The big one is our in-house patterns. So in order to avoid vendor lock-in, like Sid had mentioned earlier, how are we doing on time? In order to avoid vendor lock-in, in our applications, we abstract away all of our services so that our application developers really should not know that we are using AWS as our underlying technology. And it's really important for us to do that because we don't want to suffer the fate that we've had in the past. So that's kind of our mitigation for future freedom. And our SaaS products, Sid mentioned them before. Basically, we use AWS because that's our established provider. But basically, every service that we have in AWS, we are abstracting with our own in-house patterns. This is very personal to me, and probably finance and insurance in general. Java is king. Java is king. Statically compiled, refactorable. This makes code maintainable. I highly suggest if you guys are a Java shop, stick with it. We use Quarkus, but basically any Java is fine. But we've pretty much been sold on Quarkus because it's super easy and it is also vendor supported by Red Hat, who is our partner. For all the gaps that you have, use Bash. Bash is really simple. Bash, AI can write Bash for you. Don't be afraid of Bash. Make everything scripted. Don't let anybody write Word documents asking you to click here or click there. That takes forever. Don't do it. Don't do it. Automate everything with Bash. All right, and that would conclude my portion of the presentation. I hope that you guys have learned something or found it useful, our comments. And if there's time, we can take any questions.